Okay, so again, with division of radicals, basically we've got two types we're going to look at. The first type we're going to do is where we're going to just divide and simplify. Okay, and this is more just your standard. This is more like simplifying a fraction kind of thing. That it's even though it's not, it says division, it's more of just simplifying a fraction, dividing out by the common parts you can do in this one. So basically, here's what we're going to do. You're going to divide the radicands. Again, radicands is the inside numbers. Second step you're going to do is if you have variables, you're going to subtract exponents. And then pretty much the whole thing through this one is that, with all these parts and pieces we're going to do, you're just going to keep simplifying. And for most of these problems, they're going to have it written whether you've got one radical that's together or two radicals that are kind of separate. Basically, you always kind of do the opposite of whatever it is that they give to you. So if they give you something like this, where you have square root of 200 divided by square root of 2. All right, that for that part, you can think about that as being, again, just one big fraction that really it's like 200 divided by 2, which is the square root of 100. And then can you square root 100? Yeah. You can just simplify and make that one 10. And again, the good thing with this one is we're not worried about anything, any variables being negative at this point. When we start working with variables, they will say assume the variables are positive, so we don't have to worry about the absolute values as we're working through these. So the answer should just be whatever the answer is, and there's not really anything that you have to worry about it when it gets to that part. Okay, so let's do third root of 81 over the third root of 3. Okay, so it's separate, so you can kind of think about it being together. That's 81 divided by 3, which would make that the third root of 27. And again, that's where you want to kind of think about breaking those down. Now, with third roots, you don't think about third roots quite as much. But if it's third roots and you're simplifying these down, 27 would be 9 times 3. 9 would be 3 times 3. So 27 is really 3 times 3 times 3. So we need 3 of a kind. We have 3 of a kind. So if we have the third root of 3 to the third, a lot of 3's there. The third root, the third power cancel out. The answer is just 3. And honestly, that's one where a lot of these problems, when you're doing these, that's where you just want to check it on your calculator. And I hate to say just, use your technology, but let's use your technology. And again, if you're doing the third root of 27, to do that, you have to hit 3, hit your second, and then your power button here. That behind it's the part there, hit the rooftop button. That puts the 3 in the exponent or in the index there. And then you do third root of 27, you just get a plain 3. Okay, so that way you can kind of check it to see what it is that you're looking at there. Okay, now let's throw a few variables at you. Let's get the third root of 250 x to the 7th y to the 3rd over the third root of 2 x squared y. Okay, and again, here's where you can kind of think about the different parts and pieces of it. We've got the third root of 250 divided by 2 would be 125. And with the variables, here's where, again, you're just going to take the top number and subtract the bottom number from that. So for the x's, it's 7 minus 2 to make that x to the fifth. For the y's, again, the y is here by itself, so it's understood 1. 3 minus 1 would make that y squared. So once you've got it condensed down so that it's just one number, now you're back to like we were doing on that very first, or actually probably second day, of just breaking things down. That we're going to break down the third root of 125. For x, we're going to do 5 divided by 3. And then for y, we're going to do 2 divided by 3. Okay. And as you're going through these, again, thinking about ACT, because it is right around the corner for all my juniors in here. This is one that before I start to break this one down, I'm going to check that number on my calculator just to see if that's a perfect radical. And if you do the third root of 125, it comes out nicely. That number is just a plain old 5. Okay, for the x's, we're going to take 3 and divide it into 5. Goes one time with 2 left over. For the y part of it, when you divide 3 into 2, it will not go. So that's 0 with 2 left over. Okay, and again, when we're dividing these out, the top numbers, this will tell you how many gets out. This will tell you how much is left over on the inside. So on this one, we're going to have 1x on the outside, no y's on the outside. On the inside, we're going to have 2 x's and 2 y's. Again, just realizing that, again, this answer may not always come out to be a perfect radical for this part of it, but, just sometimes it will, sometimes it won't be. Okay, and that's your fairly basic idea of what we're looking for the first type of division where you're just dividing and simplifying. Okay, second type we're going to look at. And again, this is the part we've looked at already, so we'll go back and there's actually kind of 2 types that we'll look at for this one. We'll do one here first, and there's another type of rationalizing. We'll look at that one just a little bit later. Okay, second type, we're going to rationalize it. Okay, and then even in this one, there's actually kind of a couple of different types we're going to look at. The very first part, let's take you back to, take you back to your unit circle. That if we were doing some of the problems along the way, we got one, maybe we had something like 1 over the square root of 3, or let's make it 4 over the square root of 3. And if you do or don't remember, to rationalize this one, we said you're going to do 2 things. Top number is going to stay the same. You're going to move the square root from the bottom to the top. And on the bottom, you're going to give me the number without the square root, so that would just be 4 square root of 3 over 3. So if that was 6 over the square root of 2, so we'd make that 6, and then square root of 2 would go on top. On the bottom, we're going to leave the square root off and give me just the 2. Okay, question? So then we take 6 and 2 and divide them both by 2. So if we do that, basically just cancel that out, make it 1 and 3. So that would make that 3 square root of 2. Okay, so for square, now that was a shortcut just for square roots. So basically that, and again, that was kind of, we did that with the unit circle as we worked through finding out what secant and cosecant, cotangent, all those different things. We're basically working through and finding those parts of it. So that's kind of the shortcut just for square roots. For any other root, so for any other root that's not square root, you've got a different set of things you have to do. Basically, you have to multiply by the radical with the radicand with a power needed to be the same as the index. And this is one of those where it's as I write this and say this, it doesn't really sound very good, but it's unfortunately I cannot find a way to say it better. It's one of those where showing you the examples is a lot better than trying to tell you exactly what we're doing, but I'm trying to give you some thought process of what we're doing. So for if it was third root or fourth root or fifth root or seventh root or whatever the number may be, you've got to multiply by that same radical. So if it's seventh root we're working with, you're going to multiply by the seventh root. But then the power of the radicand is going to be different than what it was in the original problem on that thing. And again, it's kind of hard to explain it in words because I mean you could, but it would be like a whole giant paragraph. I mean that's a short like run-on sentence. We can do it if we got a whole paragraph. Sometimes examples scream a lot louder than words ever can for this case. So here we go. So let's say we're doing 10 over the seventh root of x squared. All right, and basically here's what we're going to do. We're going to take, just like we did before, we're going to take 10. We're going to multiply it by the seventh root of x. But here's where it's got to change a little bit. That basically, you just subtract these two numbers. So we've got the seventh root of x squared. That basically is what you're thinking about. If this is the seventh root, for these two things to cancel, this needs to be x to the seventh, right? So we've got 2, which means we need 5 more. So we're going to take this original problem that we have, we're going to multiply it by the seventh root of x to the 7. And on the bottom, we've got the seventh root of x squared. We're also going to multiply by x to the 5th power to get that one. And we're going to do the same thing on the top. And this one, we're going to kind of go a little bit longer on this one just to make sure we got it. We'll kind of show you shortcut-wise what we can do on the next ones here. So we've got 10 over the seventh root of x squared. We're going to take the original problem that we have. We're going to multiply it by, subtract these two, make it x to the 5th. And we'll do that on the top and bottom. Okay, top part. Nothing you can really do to simplify that one. It's just 10 times the seventh root of x to the 5th. But on the bottom, what happens if we take x to the 2nd and x to the 5th and put those together? Make it x to the 7th, right? And as long as we've got the seventh root of x to the 7th, these two things cancel, which means then we just get a plain old x there. And that's the final answer that we're looking for. So the part that's a little bit similar is that we're still going to do like we did before. On the top part, we're going to move the denominator from the bottom to the top. On the bottom, we're still going to get rid of the square roots and leave just whatever's on the inside. But the difference is if there's already 2 here, we're going to need 5 more to make this thing cancel. So now we're going to have those 5 extra ones basically on the top there. All right, so let's do 8 over the 10th root of b to the third. Okay, so again, if you subtract these two, 10 minus 3 is 7. So we're going to make this the 10th root of b to the 7th on the top. And if we add 7 more on the bottom, again, those are going to cancel. So that would just be a b. Does that seem like it's okay? So if you've got the 12th, 12 over the 18th root of x to the 11th, and they ask you to rationalize. Yeah, if we subtract 18 and 11, that's going to be x to the 7th. So that means we're going to have to put 7 x's on the bottom to get this to cancel. We also need to put 7 on the top to cancel. But again, if we add the 7 on the bottom, that's going to make it 18, which is what we want. So then it would just leave you an x on the bottom. Okay, so that's where if you can do the mental math, it will save you a lot of stuff in between. And again, there's not really a whole lot of work to show because again, all you're going to do is subtract these two, put that up here, and if you do that, then we get to cancel the bottom off. And again, technically, we're doing this where we're adding in these many more here, but we're just going to do a little mental math so we can kind of slide by it a little bit. Okay, let me give you one where it's just numbers because there's probably not a whole lot of simplifying you're going to be able to do. It's pretty much just going to be you're going to rationalize it, and that's all you're really going to be able to do. The only time you might be able to do anything with the rationalizing part is if you have one that has just numbers with no variables. Everybody good there? All right, we'll wait. All right, so one more with the numbers, and then we'll kind of move on here. Okay, let's go 4 over the 4th root of 2. Okay, so first thing again, think about it. Is this if there's not a power, that's technically 2 to the first power. So to make this thing cancel, we need 4 to the 4th power, right? So if that's the case, we need to multiply by the 4th root of 2 to the 3rd power. So then we've got 2 to the 1st power, 2 to the 3rd power. We can add those powers to get 2 to the 4th. Top part, again, that's just going to be the 4th root of 2 to the 3rd. Okay. But again, the good thing with that one is those powers cancel. So we've got 4 times the 4th root of 2 to the 3rd over 2. Okay. And then last thing with this one is you've got the 4 divided by 2. Because again, if that's on the outside, you can divide both of these by 2. So then your final answer would make that 2 times the fourth root of, and they might let you leave this 2 to the third in this case. The mouse will let you just go ahead and do 8 there. So you could do that. You also could have that. I think either one of those two should be okay. So you can either leave this 2 to the third, or you can take the 2 to the third and make it 8. But either way you go there, that answer should be the final answer that we're looking for. Okay, and as far as division goes, that's pretty much your two tops. It's either divide and simplify, where it actually kind of makes that, or you got the rationalizing part as you go through those. Okay, and then the last thing we got here that we'll kind of bring in is we're going to do some stuff with binomials. And where binomials is where we're kind of tying all the pieces together with this thing. Because everything pretty much up to this point has just been one term for a lot of stuff that we're doing. This is we're going to basically do binomial for this part. Okay, so first thing we'll do addition or subtraction. Okay, so with addition and subtraction, again, the radicands have to be the same. That with the radicands, you can think about the radicands being basically that they're like variables. That if you've got one that's a square root of 3 and you've got another one that's a third root of 3, then one of them's like an x and one's like a y. So they're different parts of that one. Indexes have to be the same. Indexes, indices, whichever way you want to say it there. I'm just going to say indexes. The must be the same. And then number 3, once those two things are the same, then you just add or subtract the coefficients in front. Again, when we're talking about the coefficients, that's what's in front of the radicals. Okay, and when you do that last step, when you add or subtract on those, just remember that the radicands don't change. It's like if you take 4x plus 6x, you don't get 10x squared. Same thing on this one. If you've got 4 times the square, or 4 squared of x and 6 squared of x, you just make it 10 squared of x. You don't make it the 10 square root of x squared as you're going through that thing. Okay, now one little add-in we'll do with this one. If you want to kind of go from this part up here. So we'll kind of want us to wait till we did some of these. I'm going to go ahead and put here. If the radicands are different, see if one or see if both can be simplified. Because a lot of times on these, you're going to have the first couple of problems I'm going to give you. The radicands will be the same. It's going to be really easy. You got it, you go with it. So we're going to make sure we got that idea. After we do it, the first couple of problems, then the radicands are going to be different. And people just go, oh, I can't do anything with it. No. If the radicands are different, then you have to look to see if you can simplify one of those, because more than likely you're going to have to be able to simplify and bring it down to a point where you could take those things and break them down and add them or subtract them. So let's say we're doing 7 times the third root of 5 minus 5 third root of 5. Okay, so first thing we're checking for is the indexes are both the same, so we're good there. The radicands are both the same, so we're good there. So now we can just do 7 minus 5. So it should equal 2. And again, the radicand part of it does not change, so your answer would just be 2 times the third root of 5. So for this one, let's say we're going to do 4 squared root of 2 plus 6 squared root of 3. Can you simplify square root of 2? As far as you can go, right? Because the radicands are different. We've got 2 and we've got 3 for the radicands. The indexes are good because they're both square root. But as far as what's on the inside, we've got square root of 2. We cannot break that down. We've got square root of 3 here. We cannot break this thing down. So they ask you to simplify this one. Your answer would be that it's already simplified. And I'm thinking Math Excel, they may not give you one like that, but if they do, they should give you a button that says cannot be simplified or something like that. Or you just put the answer back in there. Okay, so let's do 3x and then the fourth root of xy minus 15x fourth root of xy. Okay, both of them are fourth root, so we're good there. Both of them are xy on the inside, so we're good there. So on the outside, all we have to do is do 3x minus 15x, and that's negative 12x. Again, what's on the inside doesn't change, so it stays the fourth root of xy. Okay, so those first three, just pretty straightforward, not a lot to do with those because, again, radicands are the same. Where the radicands were different, again, we could not simplify those, we could not break it down. Then after that, you're just adding, subtracting on the outside, whatever the signs are, that's what we're going to do for those. All right, now here's one where we actually have to do some work with these, with adding and subtracting. Square root of 12 plus square root of 3. Okay, and don't be that person on the test that tells me that's the square root of 15. No, it's not. No. It's not square root of 15. Because again, the first rule of adding and subtracting is the radicands have to be identical as we're going through these things. They got to be the same. They're not, so this is where we get to break it down. Now, here's kind of the good news on this one. The hint is usually if you've got a radicand, you know you can't break down. If you've got 12, everybody okay, we can make that 4 times 3. But what is the square root of 4? That's just 2, right? So this thing is really 2 square root of 3 plus square root of 3. So now that the radicands are the same, we can add, in this case, the numbers in front. we've got an understood 1 that would be there. So technically this thing would be 3, square root of 3 for our final answer. Because again, some people go, yay, they're different. I don't have to do anything. No. If they're different, that's where the work really comes in. Because if they're different, then you've got to see if you can break these things down to actually get it where that it's going to do something to get there. So let's say you've got the third root of 250 minus the third root of 16. All right, and again, you can check these two to see if they're, perfect radicals. They're not. So in this case, this is where we've got to break these two things down. I'm going to go stack method here on this one. So if we've got 250, it is even, so we can divide it by 2. 125, we can divide it by 5. 25, we can divide it by 5. So if we're working with that one, we've got 2 times 5 times 5 times 5. Okay. Again, because it's third root, we're looking for 3 of a kind. Well, we just happen to have 3 of a kind right there. So that 5 will get out. That 2 does not get out because there's only 1 there, so it stays stuck on the inside. All right, third root of 16. Okay, and again, the big hint on this one is it's probably going to be something with 2, more than likely. We're going to just check it to make sure. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Okay, so 16 will be 2 to the 4th power, so we've got 2 times 2 times 2 times 2. Again, we're looking for 3 of a kind. Well, we happen to have 4 of a kind. So those 3 will get that 2 out. Once we take that part out, that 2 doesn't have any buddies left over, so he has to stay on the inside. So third root of 250 is 5, cube root of 2. Third root of 16 is really 2 times the third root of 2. Now that we've got that, same radicand here and here. So now we can subtract 5 minus 2. So that answer would just be 3 on the third root of 2. Okay, so adding and subtracting, that's where the work really comes in, because you've got to take those numbers, break them down till you have the same radicands. And then once you've got the same radicands, then you can do what adding and subtracting that you need to do there. All right, now let's show you multiplying. I think that would probably get us about as far as we can get today, because we made. Okay, so and again, basically different rules. Adding and subtracting. You've got to just add and subtract the coefficients in front. You don't do anything to the radicals. If you're multiplying binomial radicals, it's a different set of rules. So you're going to multiply your coefficients. Again, your coefficients are on the outside. You're going to multiply your radicands. Which are the numbers on the inside. And for these, I don't remember ever seeing it. Now, first thing we have to kind of say is, again, the indexes have to be the same, but I've never seen a problem so far where they've given you one with different indexes. So that part should be pretty safe. And then third thing is after you multiply the outsides, you multiply the insides. Then you simplify. Okay. And I guess kind of the good thing with this is this is stuff that y'all have done before. So it's not like we're doing like anything really new in this part of it. So you're going to have basically, if we're multiplying binomials, it's the full method. I mean, it's not really anything different. It's the same old full method we've been doing. The only difference is this time we've got a few radicals mixed in. Okay, so again, double distributed property is what the full method is. So we're going 3 times 2 and then 3 times 4 square root of 5. So 3 times 2 is 6. 3 times 4 square root of 5 means that's 12 square root of 5. Okay, and then distributed property with a 2 square root of 5. 2 times 2 is 4 square root of 5. Then we've got 8. And remember, on the radicands, if you do square root of 5 times square root of 5, that does make that square root of 25. So multiplying is basically you can multiply everything. There's no, adding, subtracting. You ignore what's really on the inside of the radicands. If they're the same, you just add, subtract on the outside. Multiplying, you multiply everything. Insides, outsides, you multiply it all together. And then you start breaking it down. Nothing you can do with the 6. You do have 12 square root of 5 plus 4 square root of 5. You can make those two things together and make that 16 square root of 5. With the 8 times 25, 12 square root of 25 is 5. So it really means that's a plus 40. And since we've got 6 plus 40, we can add those two things together and make it 46. And which one you put first doesn't really matter. If you put the radical first, that is absolutely 100% okay. All right, let's do a couple more of those, and then we'll wrap this puppy up. Just to make sure everybody's okay with it here. Everybody good there? Okay. So for this one, let's go with 5 square root of 2 minus 4 square root of 3. And then 6 square root of 2 plus 7 square root of 3. Okay, and again, just doing the full method for this thing. So we're going to do 5 square root of 2 times 6 square root of 2, 5 square root of 2 times 7 square root of 3. So we got 5 times 6 for 30. If we do square root of 2 times square root of 2, that is square root of 4, correct? But we know in that case, and we'll go ahead and write it out just so we don't do too much at one time. And we know that we can simplify square root of 4, but again, let's just kind of wait till we get there. We've got 5 times 7 for 35. 2 times 3 is square root of 6. All right. With the 4 square root of 3, don't forget the negative that goes with this one. Negative 4 times 6 is negative 24 square root of 6. And then negative 4 times 7 would be negative 28 square root of 9. Okay, so before you do any kind of mental math on this one. I'd say go ahead and just put everything out just like it is. Don't try to do too much at one time. Once you've got everything written down, now you can see you can start to break down what you need there. Square root of 4 we know is 2. So that's 30 times 2, which means that's going to be 60. You have 35 minus 24. Both are square root of 6s. So this part we can actually subtract. 35 minus 24 would be 11 square root of 6. And with square root of 9, we know that's 3. If we do negative 28 times 3, that is 24. It's 84. So now we've got 60 minus 84, which would be negative 24. And then the 11 square root of 6 would just be hanging around. Again, which one you put first, which one you put second, doesn't matter. If you put 11 square root of 6 minus 24, that's okay too. Either answer would be fine. All right, one more example, then we're done. Let's do 6 minus square root of 12 and then 6 plus square root of 12. All right, distributive property with the 6. We've got 6 times 6 for 36. We've got 6 times square root of 12 to make it there. Okay, distributive property with the negative square root of 12 times 6 means that's a negative 6 square root of 12. Negative square root of 12 times positive square root of 12, that's a negative 144. All right, so 36 is good. What happens with the plus 6 minus 6? Makes it 0, right? So 0 square root of 12, which is just 0. So basically, that's just a 0 in the middle, which is basically nothing. We've got square root of 144. Well, that's 12. So it's 36 minus 12. So that would be just a 24. So depending on the numbers, it may be that the radicals go away. It may be that maybe the numbers might go away and you may be just left with radicals. So the answer could be, any one of a number of things that, with the previous example we had up here, the answer may just be 11 square root of 6, on some of these. So you don't necessarily have to have two parts to an answer. It could be that there may only be one part to the answer that we're doing.